Hello and welcome to another edition of the H2Mare Highlight webcast. Once more, we want to give you a preview on the trends that shape and change the process industries before, just a little over 1 week from now, H2Mare actually is going to start here on the fairgrounds in Frankfurt, and you can see all those technologies, all those solutions live and hands-on, and you can experience the spirit of the process industry here in Frankfurt. And apropos live, you have the chance to join us here today live as well in our discussion. So if you have any questions or comments on our topic today, just go to Slido with hashtag H2Mare Highlight, ask your questions, give your comments, and I will pass them on to today's guest. Now, what are we all talking about these days? Well, about the transformation of the industry, obviously. We need a lot of energy to perform it because we want to be climate neutral, we want to be circular, and all this depends on large amounts of renewable energy. But renewable energy is not always where the industry is. Solar power in the desert, wind offshore, that's not where we have our large industrial sites. But as the saying goes, if the mountain won't come to the profit has to go to the mountain. And in this case, production has to go where the renewable energy is. Now, if you're thinking about moving facilities to Southern Europe or Northern Africa, the H2Mare project is taking the whole concept one step further by aiming to provide hydrogen production facilities and further processing offshore where the renewable wind energy is generated. Sounds like science fiction? Well, today's guest will explain us why this is not science fiction, but an actually achievable goal. Matthias Müller is the program manager offshore hydrogen at Siemens Energy and the coordinator of the H2Mare project, which is one of the Leitprojekte funded by the Federal Ministry for Research, the leading projects on hydrogen. So welcome, Matthias Müller.
Hi, Catherine. Thanks for having me.
Great to have you with us today, and with such an exciting topic, obviously. I just said it sounds a bit like science fiction. Maybe you can tell us a bit more about the H2Mare project and what you're trying to achieve
there. Yes. Great. Basically, we're trying to achieve the generation of hydrogen, of green hydrogen, straight out there where the wind is, so where we have the renewable energy in form of wind available out at sea, and also take this even a step further. Next to hydrogen, look also at different derivatives and how we can produce them maybe offshore as well. So this is what H2Mare is about in a nutshell. And from a structure, we basically have 4 projects that are active. One is basically giving the foundation, and this is off-grid wind, looking at the wind turbine and what do we need to change and adapt at the wind turbine level. And then we have the two big pillars. One is H2 wind, looking at the electrolyzer. What do we have to do differently with regards to doing it offshore, the electrolyzers process? And another one is looking at the power to X concepts and what can we do there also of those schemes out there at sea. And on top of that, kind of the roof or umbrella is transfer wind, which aims at basically making sure that all those information is shared to involve all the stakeholders out there, looking at different standardization topics, regulatory topics, but also from an educational point to make sure that all those topics are covered as well.
So that sounds quite complicated. Wouldn't it be much easier to just connect those windmills to the electricity grid and transport the electricity to where we already have some facilities, maybe?
Well, that's what we are currently doing. And I mean, I have a double head of Siemens Energy, and obviously we have been also doing that with the wind turbines, the electrical connection for years. But looking at grid congestion, looking at also how can we transport energy easily, now doing actually hydrogen offshore seems the next sensible step.
Yeah, but really, I think quite a challenge if you look closer at it with all those steps you need to do. One of them, obviously, energy availability. Renewable energy is always volatile. I think even offshore wind is not always blowing at the same strength. So how do you tackle the technological issues, but also the economy for the electrolysis process if you don't have the same amount of wind all the time?
Actually, that's one of the biggest questions. I mean, obviously, also always have the intermittency of renewable energies. One step to go offshore is actually to already have a bigger availability, bigger yield wind-wise. Still, one of the biggest questions that we are looking at is for the different processes who require different level of stability and storage of different media. We have to see what we can optimize on the process side, what can we optimize on the availability side of the components and energy needed. So that's one of the big questions. I don't have the answer yet.
So have you storage facilities for every intermediate that you produce in the course of the process, or how do you handle this?
It's a mixture. There are different concepts we're looking at, and I can't tell you right now whether it's a yes or no. In a general sense, it's going to be, it depends, and it depends really on some processes, and obviously along the 4 years, of which 1 year already has taken place. We're looking at different concepts to later on also decide, so does it make more sense in this process step to have a storage, or can we solve this elsewhere? But here again, it's just not a simple answer to the question.
Okay, yeah, I think it's, well, there are probably no simple answers at all in this project. If you have any questions and are expecting an answer from Matthias Müller, just join us on Slido with the hashtag H2Mare highlight and ask away, and I will pass it on. In the meantime, you're using seawater for the electrolysis process, right? So you have to desalinate it and to treat it. Is all this already in place?
This is obviously also one of the really new aspects. I mean, electrolysis itself is already something that has been around there for many years, but now doing together with renewable sources and especially using salt water is something new. Desalination by itself is nothing new as well, but obviously it's not about desalination, it's about achieving the right level, so demineralization as well, and doing all that again in a more islanded network where the power consumption also of this facility will be reflected by the wind power available. So there are systems out there that have to be heavily adopted. So it's not rocket science, but it's far away from just adding 1 and 1.
And how about the ecological aspects? I mean, if you desalinate the water, you probably put some water back into the sea, possibly with larger salinity and possibly different temperatures. Aren't there any ecological concerns about this?
I think you have those concerns or those points you have to take into consideration always. It doesn't matter how you generate energy and which format energy. There are always certain parts where you're going to influence the environment. And obviously, if we take hydrogen out of the water that's left has a higher degree of salt. So this is something we're looking at closely. And the question is now, what influence it does make to the environment, because obviously it's not going to be like the Dead Sea that you can swim in afterwards, not at all. We're talking about small percentages and changes. And here also the decentralized idea, instead of having one desalination plant somewhere with a couple of gigawatts in water going back and out, here we have decentralized different smaller spots, which from my point of view also helps. But obviously this is an important point we're going to be looking at and which we're also going to be researching.
Help me a bit more to envision the whole thing, please. What should I have in mind? Is it several windmills and I have one plant associated to, let's say, 4 or 5, or do I have a small plant at every single windmill? What would it look like in the end?
We're looking at the hydrogen generation, so the electrolyzer, it's really every turbine is going to have its electrolyzer straight attached to the bottom of the tower, which means we need less towers, which also means from this point of view less influence into the environmental area. And you will have a one-to-one match, so to speak, for a wind turbine, the electrolyzer attached to it. If you now ask for the PDX aspects, we're looking at having in the first instance also then, well, obviously studies, but also a platform that will be floating where we can test certain processes and see which processes and which way of doing them out there makes sense.
Mm-hmm. Now, I've got the first question from the audience. Keep asking if you have any questions using Slido with the hashtag H2Mare highlight. The first question, what about maintenance? Quite interesting. Is there permanent staff on site, or are they on standby? How long does it take them to get there? How do you handle this?
the basic idea and the principle is going to be the same as for the wind turbines nowadays, which are clearly not manned and have specific, well, operation maintenance contracts and schedules in place, and also the entire fleet of vessels of different sizes to get there, whatever is happening, whatever went wrong. And this is one of the critical aspects as well, obviously, that the O&M concept, especially offshore, has to be really watched in detail. But here, luckily, we have partners on board who have also a huge offshore experience already, but we now have to transfer this into a new domain. So this is just an additional research topic, to be quite honest.
Mm-hmm. Yeah, and probably you need some special stuff as well, because you have so complex processes
Exactly.
that need to be maintained. Speaking of complexity, you have the whole process chain. You have the turbines, the electrolysis, the power to X. Which components are, from the current point of view, the bottlenecks that you really need to tackle to bring the whole thing to life?
Well, I think, well, as you're saying, it's about bringing the whole thing to life, where everything has to work together. So it's about the entire system in an islanded situation where you're not connected to permanent wind or permanent electrical power, not connected to other supplies you might need as well. So to make this environment, this ecosystem work, I think is the major challenge. Every subsystem has its own challenges. If you ask me right now, but this maybe also pure out of my background, and I'm not a chemist myself, it's really also to see how the desalination works and how we achieve the degree of pureness that is needed for the water and also for other supplies for the different processes.
What I think sounds really interesting, it is a bit like landing on the moon. You have so many technologies that you could also apply elsewhere. So if you are successful with this project, you have so much that you can use otherwise as well. Big benefit, I think, of this whole concept.
Exactly. That's obviously another advantage, that we're here trying to do so many things in a positive sense that can then also be applied, and the learnings applied elsewhere. Yeah.
And have you already some idea of the products you will finally transport? Will it be like something like methanol or other liquids? Or is this just open so far?
Well, I mean, we're looking at different aspects. Hydrogen is set, obviously, but that's why we're looking at the power to X value chains and also at the different derivatives. But first of all, it's about not what we can most easily transport, yes, obviously, but also what can we in a most sensible way produce offshore, because that's one of the key ideas. And here, obviously, you just mentioned a couple of them, but it's not set in stone, and we have to see what learnings we get and what the results will then lead us to.
Yeah, really exciting. And I think of a lot of interest for many of our AHAMA participants, be it from the material side, equipment. We have another question coming. What are the economic potentials of offshore PTX technologies? And can Germany become a leader in this sector, in your opinion?
Well, I think just looking at it's one of the flagship projects where also the German government is giving funding, big funding to it, shows you that not only we as the different companies involved, or Siemens Energy being also part of it, but also the German government sees this as one of the ambitious targets as part of the national hydrogen strategy. But personally, I also believe that we as Germany can really take a leading role, and we already have a lot of experience in different renewable industries, and now we just have to transfer this and combine it with the chemical parts, so to speak. But yes, I do see a huge potential to be exported and also worldwide.
Now, mentioning the international perspective, we have another question. Is the project still open for international partners? I mean, you've just said it's a national project, but is it also have international aspects as well?
Well, obviously we have international interfaces, but I mean, it's I think apparent to quite but most of the people that in general there are so many projects going on, looking at similar aspects. With those projects, obviously we're also in touch, and there are exchanges taking place, making sure that we're not reinventing the wheel and parallel different places. But right now, specifically looking at H2Mare, yes, in theory, people could still join. On the other hand, I'm also quite open or transparent. We're already 1 year down the road, so a lot of things have already happened, also from a research perspective.
Yeah. Well, I think for those who are asking, just come to Achema and go to the H2Mare stand and learn more. I think we just touched the surface of the whole project because, as I said, there's so many aspects: materials, corrosion, equipment, the whole process chain, automation, of course. I think if everything is expected to run by itself, more or less. So when and where can we find out more about H2Mare at Achema?
Yes, so we'll be there with colleagues from the Fraunhofer Institute. Klaus Litti is going to be there introducing the overview and the vision on Monday in a session at 2:45 for about 2 hours, and he's going to be joined from a colleague from RWE, Florian Gremme, who's taking a bit an operator's view of integrating offshore wind and hydrogen. Roland Dittmeier from the KIT is going to be there. He's going to give a bit more insights into the power to X, so the chemicals behind it. And Jens Arts is also going to be there from Decima, touching a bit on the offshore value chain and the potentials and challenges we have between ecology, economy, and social aspects. So all of us are going to be there on the Monday, the 22nd at 2:45. And for the entire week, we're going to be there with the other two flagship projects in Hall 6, booth 86, A36.
Great. So if you're planning to come to Achema, make sure to pass by this stand and bring some time, because I think there's a lot you might want to ask and learn. So thank you very much, Matthias, for being with us today. And I hope to
Thanks
see you
for
at
having me.
Achema.
Yep.
Goodbye.
Thanks a lot. Cheers. Bye-bye.
And as Matthias just said, on Monday, we have the Leitprojekte, the flagship projects, H2Mare, H2Giga, and TransHyd. We have a whole day dedicated actually to hydrogen on Monday. We have the pilot projects, and we have a lot more on materials and handling of hydrogen. So very down to earth, very practical approaches here in the Congress. You have all the solutions and the equipment that you will find in the exhibition. So make sure to be there. Get your ticket now at achema.de. Download the app, prepare your schedule, and join us at Achema. See you there.